So today we are going to learn about this chapter, properties of triangle. Properties of triangle means in any triangle, like if I draw a triangle like this, in any triangle, say triangle ABC, we are using these capital letters A, B, and C to denote these angles. And we will be using small letters small a, B, and C to denote these side lengths of the triangles. Now you know that for any right angled triangle, if I have a right angled triangle like this, and this is my say A, this is B, and this is C, then I can always say that A square equal to B square plus C square. That is by Pythagoras theorem. Now this is a relation between the sides, between the three sides of the triangle. Okay, this type of relations we are going to discuss here, but not for right angle triangle, not for right angle triangle, for any triangle. Those results will be true for any triangle. Right angle triangle hole eta true hobe, right angle মানে যে কোনো ট্রায়াঙ্গেলের জন্য কোন রিলেশন গুলো ট্রু হবে সেগুলো আমরা এখন ডিসকাস করব. So basically in this chapter what we are going to learn is the relation between the 6 components capital A, B, C and small a, B, C of any triangle. So that means we are going to discuss the relation between three angles and the three sides. If there is any relation, like I have already told you, there is some relation like A square equal to B square plus C square. That's a relation only between the sides. Likewise, we will have different type of relation for any triangle like this. This is not a particular triangle. There is no 90-degree here, and it can be any triangle. It can be acute angle triangle. It can be obtuse angle triangle. Any triangle. What type of relations are there? First one is let me give number one, and this number one is known as sine rule. Sine rule. Okay, what is the sine rule? This sine rule is nothing but A by sine A. A by sine A. When I am saying A by sine A, then it means the numerator is small a and the denominator is capital A. So if I just write capital A, there is no meaning. That is just an angle. With that, I have to keep a sine or cos like that. And when I just say A, only A, it means the small a, or only B means the small b, the sides. Okay. So A by sine A will always be equal to B by sine B. That will always be equal to C by sine C. Means all these three side lengths A, B, C, they are proportion with sine of capital A, sine of angle A, sine B, sine C. And you remember how I have taken this small a is opposite to the side capital A. Eta capital A angle, এই অ্যাঙ্গেলটা denoted by capital A, এর opposite যে সাইডটা আছে সেই সাইডটা আমরা স্মল a দিয়ে ডিনোট করেছি। এটা ক্যাপিটাল বি, এর opposite যে সাইড আছে সেটাকে আমরা স্মল b দিয়ে ডিনোট করেছি। ক্যাপিটাল সি হচ্ছে this angle is capital C, এর opposite যে সাইডটা আছে that is denoted by small c. ঠিক আছে, এইভাবেই দিতে হবে এবং তারপরে আমরা এই রেজাল্টটা পাবো। দিস ইজ নোন অ্যাজ সাইন রুল। সো এরকম যদি ইকুয়াল হয়, মানে রেশিও হয়, সেম রেশিও, লাইক আমি যদি বলি 2/3 ইকুয়াল টু, অর আমি যদি এরকম বলি 4/6 ইকুয়াল টু 8/12, এরকম প্রপোর্শন ইকুয়াল টু 36/54, all they are equal, they are in proportion, or the ratios are same, then I can say all of them are equal to 2/3 also. That is the minimum ratio I can get. Means if three such ratios are equal, they will be equal to a constant. They will be equal to a constant. Similarly, here also this will be equal to a constant, and that constant is 2r, where capital R is the radius of circumcircle of triangle ABC. What is circumcircle? We will discuss that. So this is our rule, and we have to remember this rule, sine rule. What we do here is we have all the three sides in the numerator. In the numerator, we are having all the three sides, and in the denominator, we have the angles with sine, respective sine and all. So now here, say we know the value of this side. This side A is equal to say 2 or say 7. And then this angle is say 30 degree. This side is say 5. If I know that, then I can find the other 3. Other 3 means other 3 components. Here what I know that one of the angle capital A, I know side small a, I know side small b. These are 3 components that we know. কোন তিনটে আমরা জানি না? আমরা বিটা জানি না, আমরা সিটা জানি না, আমরা ক্যাপিটাল সিটা জানি না। এই তিনটে আমরা বার করতে পারবো। ঠিক আছে, কি করে? এদের ভ্যালু পুট করে দেবো যেগুলো জানা আছে, যেমন এর জায়গায় 7 পুট করব, সাইন এর জায়গায় হাফ পুট করব, বির জায়গায় 5 পুট করব, এরকম করে আমরা পেয়ে যাব। তো এটা আমরা এই জিনিসটাকে আমরা অন্যভাবেও লিখতে পারি। অন্যভাবে ইন দ্য সেন্স, আমরা যখন সাইডকে অ্যাঙ্গেলের টার্মে এক্সপ্রেস করব, টু এক্সপ্রেস সাইড in terms of angle, to express side in terms of angle, মানে side কে angle এর টার্মে লিখতে গেলে we use a is equal to 2r sine a, b is equal to 2r sine b, and c is equal to 2r sine c. You check, you remember, when I am saying that side length, I am using small c. When I am using for this angle, I am using capital C. And how did I get this? এখানে এটা হচ্ছে side আর এইটা হচ্ছে angle. So side is expressed in terms of angle. Side কে angle এর টার্মে লেখা হয়েছে। R is a constant, it is the radius of the circumcircle. ওটাতে পরে আসছি। এটা কি করে পেলাম? আমি a এখানে রাখলাম আর sin এটাকে এদিকে মাল্টিপ্লাই করে দিলাম, তাহলে a is equal to 2r sin a. Similarly, b equal to 2r sin b, c equal to 2r sin c. যদি কোনো কোশ্চেনে আমাদেরকে সাইড কে অ্যাঙ্গেলের টার্মে লিখতে হয়, if I need to express the side in terms of angle in any question, then I can use this idea. And also in reverse way, to express angle or sine of angle, in fact, in terms of side, we use same relation but in a different way, that is sine A equal to A by 2R, sine B equal to B by 2R, and sine C equal to C by 2R. This is how we use them. Both the relations, this relation and this relation, both of them are coming from our sine rule. এখান থেকে আমি সাইনটাকে, সাইন capital A, I can take it to the right hand side, and this 2R can be brought down here. Then we can say sine A is equal to A by 2R, and that's what I've written. Okay, so this is the working rule. For any question, we can use this type of relation from sine rule. Right. Now, what is the proof of this sine rule? There is a proof of this. I can show you the proof. After that, we will discuss some questions. Proof of sine rule. Let us consider a circle. Let us consider a circle like this. I mean, not a circle. First, we consider a triangle ABC, something like this, ABC, and we consider a circle, circumcircle of this. What is circumcircle? Now you will come to know. Circumcircle of a triangle is a circle which passes through the vertices, which passes through all the vertices of the triangle. So this circle passes through all the vertices, means ABC. It passes through ABC. This type of circle, which is passing through the vertices of the triangle A, B, and C, is known as circumcircle of triangle ABC. Okay, triangle ABC circumcircle bole. Now, এখানে আমি let us say this is the center of the circle. Center of the circle will be somewhere here. If I join this center with this point B and extend, this will be our diameter, one of the diameter of this circle. This is the center. This is diameter, say BD. Right, so BD is the diameter. Now we join this D with C. That is, now what we can see that this angle A and this angle D, they are angle on the same circumference, the same part of the circle. What is that? That is, if I consider this arc, on this arc I am having this angle and I am having this angle on the same side of the circumference. I mean, chord, this chord. So these two angles are equal. Right? Fine. So what we get here is angle BDC is equal to angle A. Right? Angle BDC equal to angle A. Why? They are angle on the same arc, same portion of the circle. Now, if they are equal, and then we can look at this triangle BDC here, BDC, since this is the diameter of the circle, then this angle will be 90 degree, because angle on a semicircle is 90 degree. Angle on a semicircle is 90 degree. That's geometry class 10. So this is our 90 degree angle. Let me denote it by 90 degree. If that angle is 90 degree, then this BDC being a right angle triangle, I can say in triangle BDC, I can say that sine of the angle BDC, sine of that angle, sine of any angle like this angle here. What is sine? Sine is BC by BD. Sine is BC by BD. So that will be BC by BD, and let us take the radius of the circle as R. Radius is from here, and the other part of the radius is also R. So total diameter is 2R. And of course, we know that for a triangle, capital A is this angle. Opposite to that, we have BC side. I must denote it by small a. Therefore, I can say this implies sine of BDC is nothing but sine of angle A, because BDC equal to A is equal to BC. BC is small a and BD is 2R. That's the diameter of the circumcircle. That's all. That implies A by sine A equal to 2R. Similarly, we can prove the other relations. So proof is not that important, only how to use this relation for solving some questions. I have also told you here how to use them. You can use them. Okay. Now let us solve one or two questions here. Let us take the first question here. Question, it is like this. In any triangle, ABC, prove that tan of B minus C by 2 is equal to B minus C by B plus C into cot of A by 2. We have to prove this for any triangle. And with that, we take another one. This is in part 1. And part 2, we take another question here. That is sine of B minus C divided by sine of B plus C is equal to B square minus C square divided by A square. This is what we have to prove. So there are two questions you have to prove here. Let us try to solve the first one first. So in this first one, we are having this type of angle, B minus C by 2. Tan is there. I don't know what to do with this. Cot A by 2. I don't know any idea about how to get half angle so far, because I have got only one result. শুধু একটাই রেজাল্ট পেয়েছি, যেখানে আমার অ্যাঙ্গেল এ আছে, বি আছে, সি আছে, and sides A, B, C আছে. So what we do is we start from this side length, that is B minus C by B plus. You start from this and see what we get. So B minus C divided by B plus C. This is in terms of sides, and I have told you here that if we want to express side in terms of angle, side ke jodi angle এর টার্মে লিখতে হয়, তাহলে আমরা এরকম জিনিসগুলো ইউজ করতে পারি. Let us use that. B is equal to 2R sine B, C equal to 2R sine C. So if I use that here, that is B is equal to 2R sine B minus C is 2R sine C divided by 2R sine B for small b plus 2r sine c again for small c. And you can see that I can take 2r common and that can be cancelled. So 2r is cancelled as you see here. And then from here I have got sine b minus sine c after cancelling divided by sine b plus sine c. Now, there are some trigonometric identities which I have already taught you. And if you try to recollect, যদি মনে করার চেষ্টা করা যায় তাহলে একটা ফর্মুলা আছে sin c minus sin d বা sin c plus sin d এগুলোর সেই ফর্মুলা is like this 2 cos c plus d by 2. If you don't remember, আমি আবার লিখে দিচ্ছি এখানে cos c minus d by 2. This is sin 2 cos c plus d by 2 into sin c minus d by 2. That is the formula for sin c minus sin d. And similarly, we have formula for sin c plus sin d. We are going to use them here. So this will be equal to 2 cos b plus c by 2 into cos into sin b minus c by 2 divided by 2 sin b plus c divided by 2 into cos b minus c divided by 2. Here these two gets cancelled and we get this is equal to cot b plus c by 2 into tan b minus c by 2, right? Because cos by sine, cos theta by sine theta is cot theta and sine theta by cos theta is tan theta. Now what is b plus c by 2? We know that in any triangle, sum of the angles a plus b plus c is 180 degree or pi, right? So in place of b plus c, I can write pi minus a. Because of this, b plus c is nothing but pi minus a. So b plus c by 2 will be pi by 2 minus a by 2. So that is equal to cot of pi by 2 minus a by 2 into tan of b plus c, so b minus c by 2. Cot 90 degree minus theta, cot of pi by 2 or 90 degree minus theta is nothing but tan theta. So I am now going to write this as tan theta. So this is equal to tan of a by 2 into tan of b minus c by 2. This is what I have got so far. Now let us go back to the question. They're asking about to find the value of tan b minus c by 2 in the left hand side, and the right hand side should be like this. And that is done because you can just now cross multiply, or you can take this tan a by 2 to the other side and it will be here. You can just say that the answer is therefore tan of b minus c by 2 is equal to b minus c by b plus c into cot of a by 2. Tan a by 2 came to the other side and it became cot of a by 2. This is how it is proved. Clear? So what idea we have used to prove this question? We have used the idea of conversion or converting side in terms of angle. That is the main idea involved here, and that is by using sine rule. After that, some trigonometry is done here, some trigonometric identities, and we get the answer. If I look at question number 2, I have trigonometric angle, ratio, and we have angles in the left hand side, whereas the right hand side is only sides. These are only sides. So if I had sine a, I can sine a ke ami likhte pari sine a থাকলে কি লিখতে পারি 2r a by 2r. If I want to express angle in terms of side, আমি সেটা বলেছি অলরেডি, বাট এখানে সাইন এ বা সাইন বি এরকম কিছু নেই। আমি যদি এটাকে সাইন বি মাইনাস সি তে ভাঙি, তাহলে সাইন বি আসবে, বাট সঙ্গে একটা কস সি আসবে। কস সির জায়গায় কি বসাবো আমরা জানি না, সেজন্য we will try to again start with the sides and convert it in terms of angle. So question number 2. Question number 2 is like this. We start with b square minus c square by a square. That's my right hand side, in fact. That will be equal to, okay, b square is 2r sine b, that's for b, whole square, minus 2r sine c, that's for small c, whole square, divided by 2r sine a whole square. So what I did, I have expressed side in terms of angle and by sine rule. Now here, this 2r whole square, that is 4r square, that will be cancelled, and after that we will be getting sine square b minus sine square c divided by sine square a, right? Now sine square b minus sine square c, we have a formula, if you remember, that is sine square a minus sine square b equal to sine of a plus b into sine of a minus b. This is one of the formula that we have learned in trigonometric identities. Okay, let us try to use that here, and by using, I am going to get sine b plus c into sine b minus c, whereas in the denominator I am having sine a, and we know that a plus b plus c equal to pi. So a is equal to, a is written as pi minus b plus c. তাহলে sin a এর জায়গায় sin pi minus b plus c লিখতে পারি। So I can write sin square pi minus b plus c, pi minus b plus c. And what is sin pi minus b plus c? That is nothing but sin b plus c. Sin pi minus theta is sin theta. So it will be sin b plus c, sin of b plus c into sin of b minus c divided by sin square of b plus c. So one of the sin b plus c will be cancelled, and we will be getting sin of b minus c in the numerator and sin of b plus c in the denominator. This is what we are going to get. So we have proved from right hand side to left hand side. That is also okay, it can be done, right? So this is how we can apply sine rule for this type of question. Now we are going to learn another rule here, that is number 2, named as cosine rule. Sine rule was the previous one, this one is cosine rule. What is cosine rule? Here we try to use cos A, cos B, cos C. Like for sine rule, we have used, or we have got the values in terms of sine A, sine B, sine C, and the sides are also there. And here we will be getting in terms of cos A, cos B, cos C. The rules are like this. Cos A is equal to b square plus c square minus a square divided by 2bc. Means if you know all the three side length for any triangle, say you know this side is 7, this is 2, and this is like 3. No, this is 5 and this is 3. Then if you know all the three sides ABC, you can just put their values here and you can get cos A, cosine of angle A, you can get. Okay, similarly, we have another formula, that is cos B is equal to C square plus A square minus B square divided by 2CA. And the other one is cos C, that is A square plus B square minus C square divided by 2AB. Now here you can understand there is a pattern. If I am having cos of A, capital A, then this small a is in minus, small a square is in minus. B square plus C square is here, 2BC is here. When I am taking cos B, then minus B square, small b square, CA. That is the pattern you can remember. And this formula can be written also, it can also be written as A square is equal to B square plus C square minus 2BC into cos A. What I did, I have just cross multiplied this one and then rearranged the terms. Similarly, we can get B square in terms of C square plus A square minus 2CA into cos B. And we can get C square in terms of A square plus B square minus 2AB cos C. Right? So these are the cosine rules. This is one of the form and that is other form. I mean, both are same thing but written in two different forms. You can understand when we have this type of triangle, say this angle is A, this angle is B, and this angle is C. This is a right angle triangle. So angle C is pi by 2. Then what will be cos C? Cos of C is equal to cos of pi by 2, cos 90 degree, cos pi by 2 is 0. If you look at this formula, cos C becomes 0. So this term will not be there and you see what you get. You get C square equal to A square plus B square, which is our Pythagoras theorem. Theorem given by Pythagoras. C square equal to A square plus B square. Hypotenuse square equal to sum of the square of the other two sides for a right angle triangle. So Pythagoras theorem is a special case of this cosine rule. Okay. So this is the most general case. This is true for any triangle. For any triangle, it is true. So if you know all the three sides, you can find all the angles of the triangle. If you know two sides and one angle in between, then you can get other side. So this is how we use it. Let us take one question. Question: prove that in any triangle ABC, prove that in any triangle ABC, part 1, A into B cos C minus C cos B is equal to B square minus C square. This is one question, and we are going to take another question. That is in part 2, that you have to prove that cos of capital A by small a plus cos of capital B by small b plus cos of capital C by small c is equal to A square plus B square plus C square divided by 2ABC. So these are the two questions that we are going to solve here. And you can see that there is cos C, cos B, cos A, all these things. So you can understand that we have to use cosine rule here. So while solving the first one, if I take the LHS, that will be A into B cos C, which is given in the question, minus C cos B. That's my LHS. That is equal to A into B in cos C. So cos C formula we have here. This cos C is A square plus B square minus C square by 2A. Let me write that. Cos C is A square plus B square minus C square divided by 2AB. That is multiplied with B minus C into cos B. Cos B means C square plus A square minus B square divided by 2CA. So this is the cosine rule that I have used for this question. Now we can see that some terms getting cancelled, like first of all this B is getting cancelled with that B, this C is getting cancelled with that C. And then when I multiply again, it will be A into A square plus B square minus C square by 2A minus A into C square plus A square minus B square divided by 2A again. Those things are cancelled. Now we can say that this A and this A are cancelled. So therefore we are having a 2 in the denominator, and I can take that as LCM, and then after that I will be getting A square plus B square minus C square, and we are having minus C square minus A square plus B square from here. And we see that some terms are getting cancelled, like this A square with this minus A square is cancelled and nothing else. So this is giving me 2B square and 2C square. And 2, therefore this is nothing but B square minus C square, which is our right hand side. So that is the proof. B square minus C square, that's the right hand side. Right. So what I did, I have just used the cosine rule here, and the solution is so simple. Only calculation part is there. Let's take the second question. In the second question, we have LHS like this, and RHS is only in terms of sides. So I have to convert all the cosine term in terms of side. So question number 2. LHS, the given question is cos A by A plus cos B by B plus cos C by C. So that's cos A is our B square plus C square minus A square divided by 2BC. Already I am having a here, plus cos B is C square plus A square minus B square by 2CA. Already I am having a B in the denominator, plus cos C is A square plus B square minus C square divided by 2AB with a C that is already there. Now we see that the denominator for every term is 2ABC. I can take that as LCM. Then I will be getting B square plus C square minus A square plus C square plus A square minus B square, and then plus A square plus B square minus C square. So I have just written those terms. Now I can see that this minus A square is getting cancelled with this plus A square. This plus B square is getting cancelled with minus B square. This plus c square is getting cancelled with minus c square. So I am having one c square here, one a square, one b square here. So this is nothing but a square plus b square plus c square divided by 2abc. And that is what is our right hand side that we have to prove in this question. Right. So this is how we can solve different type of question by using cosine rule. Let's take another question. If in triangle ABC, A plus B plus C into B plus C minus A is equal to 3BC, then show that our angle A is equal to pi by 3, 60 degree. We have to show that the angle A is 60 degree. Okay, so see what we get here. If I multiply them, I can see that if I consider B plus C together, here also B plus C together, it looks like A plus B into A minus B, that is A square minus B square. So I get from the question is B plus C whole square minus A square equal to 3BC, which implies B square plus 2BC plus C square, that is the B plus C whole square formula, minus A square is equal to 3BC, which implies B square plus C square minus A square. Why am I keeping like this? Because I have to find the value of A, and you see how I am getting it, is equal to BC, because I am having a 2BC here at 3BC here. It will go that side, it will become BC. Now this implies B square plus C square minus A square divided by 2BC. Why did I divide by 2BC? Because this is the formula for cos A, cosine rule, cos A. I have to find something about A. So cos A I have got here. And in the right side, what will I get? It is nothing but half. Because there is a BC here. If I divide by 2BC, BC will be cancelled. Only half will remain. And then this implies cos of A equal to half. If cos of A is half, what we can say? We can say that this implies angle A is nothing but pi by 3. Okay, so that is how we can solve this question simply by using cosine rule. This whole thing is our cos A, and everything is in terms of side. সবগুলো সাইডের টার্মে আছে, কিন্তু আমি suddenly আমি capital A পেয়ে গেলাম. That is how these rules are important. Let's take one more question. In this question, it is given that if in triangle ABC, B is equal to 2, small b is 2 side length, and small c is equal to 1, b is equal to 2 centimeter, some unit is there, c is equal to 1 centimeter. These are the two sides given for the triangle ABC, and it is also given that angle A is 60 degree. Then what you have to find? Then you have to find angle B and angle C. Angle B and angle C for triangle ABC. You have to find them. Okay. Let us see how we can solve this. Okay, so two sides are given, B and C, and angle is also given. So what we can do, you see this, which sides are given here? Small b, small c, and capital A angle is given. And you see this cosine rule that I have written here. I mean, same cosine rule written this way. Here, small b, small c, and capital A, they are present in the right hand side. If I put those values here, I will get small a value. Let's see what we get here. I don't have to find small a. I have to find capital B and capital C. But let's use this cosine rule. We have a square equal to b square plus c square minus 2bc into cos A. And this rule implies a square equal to b square. B is 2, so 4 plus c square is 1 minus 2 into 1 into cos A is half. Cos 60 is half. So what are we getting here? Value of a square is 3. That implies the side length of A is root 3. Right? So we have got that. Now, by cosine rule, I have got this. This is our cosine rule. Now, what are you going to do? I am going to use sine rule. You see what I am doing here? A by sine A equal to B by sine B equal to C by sine C. This is our sine rule. By using this sine rule, now I am going to get the remaining part of the solution. That is, in place of small a, I am going to put root 3. And sine of a, that sine 60, is root 3 by 2 equal to small b, which is given as 2 in this question, by sine b equal to small c given as 1 by sine c. So in this, everything is known except sine b and sine c. If I just consider these two, I will get sine b. So this implies sine b is equal to 1. And sine c is equal to, what will I get as sine c? That is half. If sine b is 1, then b will be 90 degree or pi by 2. In this question, it is given in terms of degree, so I will also write in terms of degree. Angle B is 90 degree and angle C is 30 degree. And you see, sum of all the angle should be 180 degree for this triangle. That's perfect here. Okay. Right. So this is how we can solve questions by using sine rule and cosine rule wherever it is applicable. Right. So that's all for today. This is completed now.